very important. Means you need to have this tools ready for implementing the algorithms. So last week we saw a quick introduction of the Python language. So today we will see two topics. I'll jump through the topic. These two topics are extremely critical for you to implement the machine learning algorithms or any data science problems. So the first is the conditional expression, which is the if condition. Typically, you know, right? So every language supports this conditional expression. Let me put this here so that, okay, this is good. Okay, here would be the right place to keep this. Nowhere. Okay, so the conditional steps, typically what you want to do is your code by default execute in a sequence. The first sentence will be executed. Last week we talked about that, right? The keywords collected together will form a valid Python sentence, and multiple Python sentence will form together a particular topic or a program. So typically the execution flow of a program is very sequential. It will execute step 1, 2, 3, 4, 5, 6. But it is very important that if you do understand this if condition, so it's pretty much similar to other language. Here you have to understand means the syntax. So the syntax, one thing here is means you use a colon. First, you have to use the if condition. You have to use the conditional expression. And then a colon. And after that, you have to indent the block that comes down the if part. And then if you need to go for else, again, you have to indent. So in this particular case, what is going to happen is if x is less than 10, print smaller. And if since x is less than 10, this 20 will not be executed and the final part will be executed. So whatever, if you want more statements under here, you have to put it here. The biggest difference is of this Python from the other programming language you have familiarized is in C, you use a curly bracket to identify a block. In Pascal, you use a begin and end. Here, it is intended. So if you don't intend this properly, you will get an error. So the key thing of a condition is how to compare. So it is using Boolean expression. You have, these are the Boolean parameters. So you can have less than or equal to, greater than or equal to, greater than and not equal to. Mind you, this, when you evaluate an expression using a conditional comparison operator, when you evaluate an expression using a comparison operator, what is going to happen is it will always return a true or a false. And the whole execution of the if condition would be based upon what exactly is being returned. If it is true, the first part of the expression will be executed. If it is false, the else part will be executed. That's what it is. So in this particular example, you can see that everything is used equal to, greater than or equal to, less than or equal to, everything is used. This is exactly what the comparison operators. And depending upon whether it returns true or false, accordingly, the expression will continue. So sometimes the decision can be one way. So that means there is an if condition. And if that condition is true, a sequence of statements will be executed. If it is false, it comes here. And if it is true, what is going to happen is all these statements will be executed. And finally, it comes here. That's how it happens. Indentation. So the indentation, as I said earlier, indentation is extremely important. So intent is what is going to define a code block. So it defines the scope of the block. So if there are two ifs comes within a code, what is going to happen is the indentation is going to tell what exactly is the scope of the first block, what exactly is the scope of second if. And when you reduce the intent, when you increase the intent, it defines a new block of code. And when you reduce the intent, it will revert back to the end of that block. So in Python, the blank lines are ignored. The comments will be means completely ignored in the indentation. So please pay attention to this indentation, because this indentation can give completely unexpected results if you don't pay attention to this. So just keep in mind that whatever you use in curly bracket, if you're familiar with C, it is substituted with this indentation in Python. So this is what happens. So it means you can see this particular portion, like initially this, if x equal to 5 and all these yellow are in that same intent, and then what is going to happen? So you are intended these two. So if x is greater than 2, what is going to happen? Can you tell me what are all the statements will be, statements, how this is going to print?
Bigger than 2, still bigger.
Both the statements will be, means all the three statements will be printed here. So this will be used with if loop, and this will be used with the for loop. So this is pay attention. That is why it is shown in the slide in detail. Now you can use if within an if, because if a condition is true, you can check another condition. Then the indentation will become more critical. We can see that here in that first intent, the scope of that first block is this much. But the thing is, within that first block, there is another block. So in this particular case, right, in this, what is that?
If the indentation is not correct, I mean, if the nested loop
Absolutely wrong. So let's play some, means let's try to do some example, right? So in this particular case, if x equal to 42, what would be the result? What exactly will be printed on the screen? Can you tell me? If x equal to 42, what are all the message that will be printed?
It will print more than one. Then it will print the all done.
Is it true? X equal to 42. So what means that exactly the point?
More than one.
Yeah.
Less than 100 and all done.
Right? Exactly.
It print, yeah, it print all that. Yeah.
Yeah.
All of it.
Yeah. Yep. So that's what it is, right? So x is greater than 42. All these three will be printed, because this is one block, but that block contains another block. So that's what it is. Now the two-way decisions. So we talked about one-way decision, two-way decision. Keep this high-level syntax in your mind, right? If condition, then a comparison operator. See, that comparison operator can be even complicated operator, right? So you can combine two logical expression using the Boolean operators, and or not. So that's all possible. And you can make it very complicated. You can have 1 or 2 or 3, 4 comparison operators. So that can happen. So then you can have yes, execute a particular block of code, no, execute another block of code. That is what is shown as if and else. So this is the example. These are all fundamental things, but just make sure that you got the syntax in your fingertips when you do it, because otherwise it's very easy. You may think that this is easy, but mind you, when I started first time reading Python 1 year back, I thought it will be very easy for me because I've done C, Pascal, all the programming language. But when you code, you always make mistake. So plus just do 1 or 2 exercises and the syntax will come to you. Now I don't do this coding on a day-by-day basis, but still it is very, very clear to me. So more conditional structures. Then in Python, actually you have a unique expression. It is called elif, because if the condition is wrong, then you want to check another condition. You don't have to write else and then another if statement after that. You can use this elif statement. So elif means it is if the condition is wrong, you're checking another expression. Now the point is, one thing that you can make always mistake is this else. This else means when you use elif, the next time you use else, it will be always belonging to the previous elif at the same level. So this else belonging to this elif. So in this particular example, right? So if x is less than 2, what is going to print? If I put x equal to 1, what would be the result?
Small. Small, all done.
Small, all done, exactly. So if I put x as 4, what is going to happen? What would be the execution flow? It will evaluate this condition. So this is not true. So it will come here, execute this, and check if x is less than 10. That is true. So it will print medium. And this else is belonging to this elif. So that this will not be printed. And then it will print all done. Right? So that's the trick. And let's take this third example. If x is greater than 10, what is going to happen is this condition will fail. So immediately control will go here and it will check if s less than 10, no. And immediately it will come here. It will print large and all done. Clear?
Yeah.
Okay, beautiful.
But is can a elif followed by another elif, or you have to toggle between elif and else?
You can follow multiple elifs. That's exactly what I'm going to show you now. So you can have multiple elifs. I'll show you one example immediately. So this is what the multiple, look at this, Mahesh. This is what you're asked, right? So here, what is going to happen is, so you want to, means say small, medium, big, large, and huge, right? So you put the input value 5. So what is going to happen is, it is less than 2, no. It comes here, less than 10. Since less than 10, it will print medium. And what is going to happen? Elif, no, this condition is true. All these are, this elif belongs to the previous elif. So this elif is true. So it will directly goes to the end. That's it. Because this else belongs to the previous elif. And this elif belongs to the previous elif. This elif belongs to the just previous elif. And this elif belongs to the previous. This is the maximum complicated scenario. So I just wanted to show that. Clear?
And if in the end we have another else, right, we could, that would be, is it possible to have, say, else?
That will be an error.
Error? Okay.
Yeah, because see,
You only have one else.
technically what is going to happen is, this is the else of this if, right?
Okay.
Right? If, look at this. If x is not less than 2,
Okay.
that is the else. And that is that else, elif. So elif is a substitution of the else.
Yeah. Makes sense.
But instead of else, what is going to happen is, it is checking another condition.
Yeah.
Else means you're not checking a condition.
Mm.
Correct? A block of code will be executed if that is false. Whereas if it is elif, it is checking another condition and
Right.
giving you another opportunity.
Yeah, but if we want, we could have, say, if, then else, and inside the else another if, like a separate.
Absolutely, you can have it. Any number of nested if you can have it. So it is up to you. These are all tools available to you. Depending upon your unique scenario, you can use elif or else. But this elif, in my experience, I haven't seen in any other programming language. It could be
Yeah.
there, but of course, the last programming language I saw was long time back. So, but this was very interesting to me. This is very useful. Okay.
Rajesh.
Yeah.
Yeah, I was wondering why there's no end if. Would have avoided confusion with.
No, end if is not required, because end if is required. Why do you need the end if? Think of this.
Otherwise, we have to be very careful with the intent.
The compiler to say that that block of code is ended.
Right.
So one of the design principle of Python was what? They wanted to resemble this to the natural language as much as possible. If you put a curly bracket, if you put a if and if you put a begin and end, all that is not, it is deviating from the natural language convention. So what they did was, in a simple language, you use indentation, you use punctuations and the commas, etc. So indentation is what is going to define the scope of your block, because end if is also technically defining the end of that if block. So that's what happens. So this was the design principle of Python when they designed the language. Obviously, any language can be designed when it is defined in the way they design the print language, right? So the way they wrote the compiler was this, and this is what the design principle was. So, but be careful, because if you don't pay attention to this, you'll get totally unexpected results. So that's why I wanted to highlight this. The block and the else, elif. Okay. So
at
here,
the end of that block, after the else, you had one statement. If there's another statement after, say, a space after that, will it execute that as part of the if, or will that?
this is not part of the if. This particular print will happen no matter what. So,
but if you push an intent, if you put the tab and make it same as the previous print, it'll be part of the else.
Exactly, it will be part of that else if. So intent is going to determine which block it is belonging to. So to Jeevan's point, if you put one tab here, what is going to happen? This will be printed only if s less than 10. That's it.
Right. So the print all then will be along with the previous one if there's intent along.
Yep. So the next one is multi-way. So tell me what exactly is going to happen.
Rajesh, one quick question. If we were to reverse, slightly change the order of elif, let's say after the first statement, can we go back to the previous example, please?
This example?
No, the elif example, the next one, the multi-elif example.
Okay. Where did I put that? Okay, it's down. Yeah.
Yeah, here on the right side, if we were to change after elif x less than, if x is less than 10, and if we reverse that order a little bit and say if elif x is less than 100 and go in the reverse order, then it should print huge, large, big, and medium all together, right?
Yeah.
Okay.
No. That's it.
No.
That won't happen, right? So let's talk about that. So if I understand correctly, what you said is elif if less than x less than 100, right?
Yeah.
It less than 100, you put a block of code, and then it will not even enter any of these block, because this is an else of this if. So
okay.
If x is less than 100, right, then it won't come here at all. Otherwise,
okay.
You have to put the value of x, which is above 100. So if it is above 100, this will not execute, this will not execute, this will not execute, this else will be executed. So just consider the elif as an else of the previous if. So in other, elif could be the else of a previous elif, or it could be the else of a previous if. Right? It's either or. That is why it's a conditional expression. Conditional expression means you evaluate the condition. If it is true, it will execute one branch. If it is false, it will execute the other branch. So elif is an else of the previous if, or the elif is an else of the previous elif. These are the two possibilities. Please do some example. Just if you want, means this is there already in OneDrive. You can go there and try to do this example. I did this example, means I practically wrote this example on the notebook and did that. So that's what gave me a little bit more, what do you call is the fluency of the language. Only you get the fluency of the language only by doing it. It's easy to read and understand. But if you want to do something, you need to do it. Okay, so, sorry, where is that? Here, can you tell me what exactly is going to print? This left side.
One.
What's the value of x? Beginning value?
Okay, so put x, whatever is the value, right? Let's say that I put x equal to 5.
It's equal to 5, you just say print something else and it will come out.
What is that?
If you print something else,
No.
So something else will never print.
Exactly.
Yeah.
It will print 2 or more, right?
Yeah. Now the reason why we put that example is for what? Just to put the statement I took earlier. Else would be the else condition of a previous if. Else if elif would be the else of a previous condition, right? So if s, let's say that x equal to 5, what is going to happen to this condition? Is what is going to return for this condition? True or false?
False.
False. Naturally, it will revert to elif. If
Right.
x greater than or equal to 2 means what? Is it true?
True.
So then what is going to happen? This
And
will be printed. And this else will not be printed because
executed.
yeah. So the why I said this won't be printed, because all the possible conditions, whatever number you enter, it would be fit within these two conditions, correct?
Yeah.
So this will not be printed at all. So pay attention what exactly you write on the conditional expression, especially when you put multiple nested conditions. Pay attention, especially with elif. It can go completely out of control. One of my teacher used to say, like, when means in C you study the pointers, right? Pointer means you put a star. That is how you put pointer. So one of my teacher used to say, don't put too many stars, you will be seeing stars. That's exactly what happened. Okay, so now there is something called try and except. Okay, so we are flying through the code, right? So a traditional Python class, you will go and do all these examples. I'm assuming that all of you are matured enough to go back and practice. The next example. So what is exception handling in a programming language? Have you ever thought of a programming language and exception handling?
Yes.
Condition where if none of the code data output is matched, then you have a general bucket where this will be thrown.
Yeah, let me show you one example. Anybody has Jupyter Notebook open? You can share the screen. I'll tell you to write one code. We will see the exception issue. Can anybody share the screen with a Jupyter Notebook?
No, I am in a different screen with.
I will do. I have to log into Jupyter Notebook.
I have Jupyter, but I'm not logged in.
No problem. I can do that. So okay, sure, Notebook. So just look and see what I'm doing, and so Python learning. Okay, we got it. Okay, so I'm going to write A equal to input, enter a number, or let's say that enter age. And you wanted to see, how, means after 10 years, what would be my age. So how do I write the program? So let's put this as age. And I'm going to say that age after 10. What would be the value? Can you tell me?
X plus 10.
Ax, not x, age plus 10, you mean?
After 10 years from now, right?
Okay. And I wanted to print the output. What? Age
Age
after
after
10
age after 10.
years. I'm going to say, comma,
Age after 10.
right? If I execute, what is going to happen? Let's run.
Yeah, it will
25.
35. No exception.
Why? Remember, the other day I said the input function always returns what? String only,
Right.
right? So
So you have to int.
you have to use int or float, because I can always say that 10.5 as my current age. Okay. So now I'll say 20, 30, correct? So this executed fine. So now what if a user is going to say ABC?
Exception.
Yeah, because we're trying to convert the string to a float.
Correct. So how, and what happened? Your program, the program crashed. So you have users wrong action, users not correct and incorrect action can crash your code. Is that a good programming practice?
No.
No.
So how do you protect your program even if your user is doing something wrong? That's what is known as exception handling.
Yeah.
So you wanted to monitor a piece of code where you are doubtful whether the user will execute it right or not. So that's what it is. So how do you do that? It's very simple. What you have to do is you have to put something called try. So where exactly you want to try? Where exactly the error can come? This is where the error can come, right? Because when you convert the age into float, if this is not a number, what is going to happen? So you are going to say that try this particular portion of the code, right? So try means you wanted to monitor that particular portion of the code. And if something happens, if the code crashes, you don't want the code to crash. Rather, you wanted to execute something outside, right? So you can say that except, it means whatever, whenever there is an error happens, it will go to that next block. So you can say that except.
Try and accept.
Yeah. So,
just like the try and catch in the other languages.
Exactly. That's it. So what happens is Python will try what you have written here. And if that is wrong, so here you have to indent properly, right? Because try is a block. So everything here will come like this, and except you can say that print, what you can say that enter proper age.
The
Yeah.
brackets.
Correct. Okay. So now if you go and execute it, if I say Bob, it didn't crash.
Right.
That's the purpose of this exception handling. Clear? So it's a good programming. It's better to use wherever there is a possibility of crashing the code. The code will not crash the program, meaning that wrong action will not crash the, if at all Python throws an exception, it will not crash the program. It will come here directly.
I'm surprised that it didn't complain about the indentation.
Why?
Because you have different indentation for try and accept.
That is fine. Like it just say that which level it is. because this is one block of code and this is another block of code. This will end here. That is over. Whereas if I had used in the same block, it would have been a problem.
Rajesh, is there a indentation required for the try? Because there is a try and catch. Sorry, try and accept, right?
So how many statements will be there if I put try? Yeah.
Anything between try and accept, it should work, right?
Let's try. Yeah, you have a point. So hopefully it will work. Let's try. I never tried it. Let's try. Yeah, it's an error.
Expected indented block.
Exactly. So that's a good programming practice. Better organize all your code under one block. That's
interesting.
It's good, right? It's a good practice because you have to follow that. This means your under whatever comes under try is a separate block, and that separate block has to be intended. Ideally, use tab for indentation because that will give you the same intent.
Plus, I guess it's easier to read also.
Yeah, it's easier to read. Okay. So this is what I think I just explained with one example, everything, all that. This is what I did. This is exactly what happens. Try, accept. Okay. This is what is the summary of the conditional conditions, right? So comparison operators, you need to be familiar. You need to be familiar with the nested decisions. You need to be familiar with indentation, multi-way decision using elif, one-way decision, try and accept, two-way decision, if and else. This much are the topic we covered. Any questions?
No.
Okay, let's move on. So this is, can you do this? So I'm going to say that, I'm going to tell you the problem. So the pay computation, right? So accept a number from the user, which is the total hours you worked. First, for two numbers accept from the user. One is ask the user and get the number of hours you worked, ask the user the pay rate. So the first 40 hours, use the regular pay, and the above 40 consider it as an overtime and use the 2 times the rate or 1.5 times the hourly rate. Tell me what exactly is the output. If you enter 45 hours and the hourly rate is 10. How do you do it?
You lose the first 40 hours with $10.
Correct. How do you, no, that is simple. The logic is simple, but
yeah.
How do we do that with if, else, elif, all these conditions?
So if the entered hours are greater than 40, then you put the extra hours in a variable.
Then you subtract from 40.
So what,
the remain.
What do you do first?
First, you will ask for the input, and then once the input is there, you will write an if statement for the first part for which you're asking for the number of hours.
So I put enter hours. Okay. I put rate.
Convert them to integers.
Okay.
If hours is less than 40, less than or equal to 40.
I guess you can do exception handling also on this.
Yeah, you can complicate it whatever way you want.
Right.
If it is
hours is less than or equal to 40,
then hours star rate.
Print rate multiplied by.
The reason why I was telling you to do it is when you do it, you will get the syntax, right? Look at the way I put the colon and indent automatically. You have to get that fluency.
Right.
Pay equal to What?
Hours times rate.
No. Hours, if it is less than 40, right?
Right.
Yeah.
40
Hours times rate.
Yeah.
Okay.
Print.
Yeah. I mean, what
Else
else you do?
else if, or whatever LF.
Just else.
Why do you need elif?
Just else.
Else.
Or just else, yeah. That's good.
Pay equal to?
Into hours.
Float hours times 1.5 times rate, right?
No.
No, you have to
It will be
subtract.
No, float hours minus 40.
Yeah.
Yeah.
Float hours
Yeah,
minus
correct.
40
Yeah.
multiplied by
Correct.
rate.
Yeah. Yeah.
Right. Minus 40
Multiplied by rate. Float rate.
times 1.5, right?
Yeah.
Times.
Yeah, 1.5 rate. Float.
Yeah.
Where is my?
Rate times 1.5.
Multiplied by.
That's what I'm looking. The keyboard stuff.
It's on 8. Yeah, shift 8.
Okay. Yeah. Okay. Shift 8. Yep.
Shift it, yeah.
Star what?
1.5 times the
Rate. Yeah.
But this will only give the hours more than 40, right?
Right. Then you have to do plus
Yeah.
plus 40 into rate also.
40 times. Okay. Plus what?
Plus in brackets float of rate into 40.
Okay. Exactly.
right.
So now what you do? Where?
Below one more line.
Intent to the left. Intent to the left. Left. Yeah.
Yeah, left.
Yeah. That's why the intent is very important, right?
Yeah.
Total pay.
Yeah. Comma pay.
Equal to comma
Pay.
Pay. That's it.
Rajesh, it's not 1.5. It's not. There's no 0.5 there next to 1 point. And if you run it, it may just multiply.
Oh yeah.
Plus after the 40, you need a into.
Yeah, into. I put
Yeah, to the power of.
power of. Okay.
So 48 hours maybe. Yeah.
Yeah. So when you use this assure, in between your kernel will stop. So you may have to restart the kernel if that happens, because it is taking from cloud, right?
Mm-hmm.
So that's a problem. Oh, the other.
We have a parenthesis missing in the second pay.
Oh, okay. Yeah. Parenthesis missing. If int hours 40. Yep. Oh yeah, here.
After else, do we need a colon?
Yes, we need a colon.
Yes. Yeah.
Invalid syntax.
Oh, we didn't put that bracket.
Bracket.
After the 40, yeah. Right. Into hours.
I don't think we need a bracket here.
No, we need. No, we got the extra bracket.
Yeah.
No, we need a bracket there.
Yeah, because into you're converting, right? Int.
Yeah, you need a bracket.
Yeah. We need a bracket there, but not at the end. Yeah.
At the end, you don't need a bracket here.
Right.
Invalid syntax. Okay. What is that? Let's say.
Oh, it's it's colon.
Yeah, colon
needed, right? So why is it saying that pointer to the colon?
No, it's not pointed to the colon. It is just pointed that to statement, right? So if int less than or equal to 40, so let's see how many parameters are there. So int hours is there less than or equal to 40. Seems that is correct. Okay. So when you get this, What do you do typically? You wanted to see if this is if. Okay, let me stop this and try to execute it. So here the if state. Why it's crashed? That's a problem with the. Okay.
Line 4, same line.
Okay, so that's what I typically do is if you want int of hours, that is correct, less
You
than.
put by any when in the first two lines itself, can we convert the input itself into int?
Yeah, that's the good practice. Now it's fine. So if I put 50, rate is 10, you got the answer. That's it. So the good practice is you can always convert this, because look at this, you're converting this int and float everywhere. So you can just convert that and store somewhere here. That way you don't have to repeat it. This is what it is. Okay, so let's go to the next topic. What is a function? By any means, in any programming language.
It's something that you want to call again and again. So you make it a function.
Structured programming is there, right? So if a block of code is repeatedly used throughout the program, what you do, you organize that in some place, give a name, and then you can repeatedly use. So in Python, you can use that using something called a function. How do you define a function? Use a keyword called def, and then you put a colon, and then intent, everything under that. Means intent means you define a block, and then you call this function anywhere from the program. So here what you did is you divided something called a thing. You'll just say print hello and print fun. So when you call this, what is going to happen when you execute this code?
It's going to print hello and it's going to print fun.
Then what is going to happen? If you execute this program as a whole,
then it will print zip and then hello and fun.
Correct.
Hello fun, zip, hello fun.
Correct. That's it. That's exactly what is going to happen.
Okay, because the first thing will say hello fun, then you have zip, then you have hello fun again.
Correct. Exactly. So that's what it is. So there are two kinds of function. One is called a built-in function. Other one is user-defined function. Built-in functions means they are part of the programming language itself. The people who developed the language have created the function for you. We used int, float, all these are previously written input. Then we use define functions by ourselves. So once you define, means these keywords you cannot use. And once you define a function, you cannot use that as a variable name thereafterward. The function names cannot be used as a code going forward. And then in the function, there is something called arguments. What is argument?
Parameter.
No, the value of the parameter. So you define, let's say that you define a function for squaring, right? Square. So parameter means you define a variable, right? When you write a function, you will say that square int of a. Then means in your program, the function, the code of the function, it will say that a square and return a square. So when you execute the code, you will call that square of 5. What exactly is the actual value that is passed to a function is called as argument. Whereas a parameter is something that is used to define the function. When you define the function, you don't know what exactly is the value that is coming into the function, right? When you define the function with a variable. And when you call the function, you gave a value for that variable. Or you use a variable for which a value is already defined. You will say that square of a, but the value of a should have been already defined. Otherwise, it's an error. So argument is what goes into the function. whereas parameter is something that you define, used to define the function. So here in this particular case, this hello world is known as argument. And whatever you send back, that is result. So a function is means the set of code that is used to store, means define the value. And some of the common built-in functions, the type conversion functions, you know that, type function, float function, etc. Then string conversion functions are there. You can convert, because we have seen that earlier. Whenever you collected an input, the value will be a string, and you can use integer or float to convert that. But mind you, if the string does not contain a numeric character, and if you use an int or float function to convert it, what is going to happen? Remember, we studied the exception, the try and except function. You'll get an error, right?
Correct.
Yeah, that's what it is. So your own function means you have to define the function first. So this is how you define the function. It's very simple. So here, what I do is I defined a function, print lyrics. What is going to happen is I put something there, and then in this code, when I execute this, what is going to happen? X equal to 5, I'm writing print hello, and then I put this, and then I put print yo, and then I said like x equal to x plus 2, and I said print x. When this code is going to execute, what is going to print, what will be printed on the screen?
It won't do anything with the function because it's not being called.
Exactly. So even if you define the function, unless and otherwise the function is explicitly called, nothing will happen. So when the Python execute this here, like it will just go to the next line. But here, if I call print lyrics, at that time, what is going to happen? It goes here and execute it.
Right.
Got it?
Yeah.
So have you studied data structure? Means some of you might have studied data structures, right? So the data structure tells you how the functions are implemented. There is something called a stack. So this function will be stored in a stack, and when you call the function, what is going to happen? The arguments will be passed there, and the results will be returned.
Correct.
And there is something called a recursion. Have you heard of that? I'm going to cover that later, but have you heard of that? Just a sneak preview.
Yes.
Yes.
What is recursion?
The function calling itself.
Correct. Can you give me one example? Use a recursive function.
To count number of words.
Factorials, right? 5 factorial, correct? So you can write a function, calculate the factorial. So you can say that if value means the parameter is not 1, you call n is the parameter. So if n not equal to 1, call factorial n minus 1. So it comes there. It will check whether n minus 1 equal to 1. If that is not 1, it will call again the previous one. So if you call for 5 factorial, when that function will be executed, it will call the 4 factorial. Same factorial function with a less parameter. Then 1 minus less, the current parameter. Finally, it reaches 1, it will return, and then the next function will return, the next function return, and finally. Recursion has some performance issues. So later point of time, I'm going to tell what should be used for deep learning, what cannot be used for deep learning, machine learning, etc. So the biggest advantage of function is once you define the function, you can call or you can invoke as many times as you want. And then you can store and reuse. That is the key idea. Then arguments. Argument, I already explained, the value that is passed into the function. That is what it is. Here in this particular case, this is the argument. Whereas parameters is the variable that used to define the function. This is the difference between argument and parameter. So argument is the real value that is passed to the function. Parameter is the variable that is used to define the function. In this particular example, let's say, look at this. So here lang is a parameter, whereas when you call that function, you use the definite value, and this is an argument. Got it?
Yeah.
Okay. Okay, so return values. Sometimes what happens, a function can return a value, right? So what you have to do is just say return whatever is the value you want to return. That's it. It's part of that function definition. And when actually the value of whatever you put as the value here, it will be returned to the calling expression. So here, when you call this function greet, you will get a value string here, and that will be printed. So that is return. And immediately when you see the return, the control will stop there. So they call it as a fruitful function is one that produces a result. And a function that does not return a value, there is a technical name called that. Means it's in the data structures and in the programming language. Anybody remember that? A function is called a fruitful function when it returns a value. And a function
null.
void.
Is it a null function?
Void.
Yeah, exactly. Null or void. That's exactly what it is. It's a void function or a null function when it doesn't return a value. So this is how it happens. Argument will be passed to the function, and the function will be executed using the parameter. And when you pass the argument, what is going to happen? This parameter will be defined with the argument or substituted with the argument. And finally, the result will be returned, and that result is known as return value. So this is the entire aspect of a function. You use multiple parameters or arguments. When you define the function, you can use multiple parameters. You just need to use that. But you can only use one return function, but you can use multiple input parameter. That's it. So void function or non-fruitful function or null function, that is a function that doesn't return a value, is called null function or a void function. Now, where to use function and where not to use function. So you can organize the code properly. If the thing is used only once, and if it is not that much required, don't use the function. But if it is a complex logic is there, and if you think that that is reusable in other modules, then use it as a function. That's a good programming practice. So the summary is, we talked about function, we talked about arguments, we talked about built-in parameters, then we talked about results, meaning fruitful function. We talked about the type conversions, integer and float, means you can convert a string value to integer using the int keyword, and you can convert an integer value to a string using str keyword. When you convert a string to an integer, if the string doesn't contain a numeric value, it will give an error. The function, we talked about string functions, and we talked about why we use function, and we talked about the difference between arguments and parameters. So that covers the second lesson.
Can I use function within a function?
What is that?
Can I use a function within a function?
Of course. Of course. You can use a function within a function, and you can use any number of nesting. But the more nesting you do, it becomes more complicated. Okay. Practice.
Rajesh.
Yeah.
How do we pass values into these functions?
Oh yeah, that's
multiple
simple.
parameters.
Yeah, that's very simple, right? So I gave you one example here. Can you see the screen?
Oh, okay. Yeah. And when you return it, can you pass multiple values back?
No, you can return only one value. In most of the language, it is like that, right? You can return only one value. But you can return a complex value. Within that complex value, you can have multiple values if you want.
Yeah, can it return arrays, kind of complicated data structures?
It can. Yeah. See, there is no built-in array in Python. So there is a library called NumPy. It gives you an array which can be returned.
Okay, cool. I have a general question, but I can wait till the end of the class.
And it's over. Like we covered today's topic.
Oh, okay.
You can shoot.
Yeah. So far, what the Python, that the spider that I see is, I know it's an IDE. The output comes in a console. It is not its test purposes is good, but how do I get to a finished product with nice user interface, packaged executable?
Yeah, you can use
product.
You can download Visual Studio if you want. IDE is only a tool which gives you an interface to the programming language, which is the interpreter here. So I personally use this one, the Azure. This is fairly good because it gives good compilation error, etc. So I think Rajesh can help you with Anaconda, meaning if you download the Anaconda.
Yeah. I have Anaconda. I downloaded. My question is more of on a commercial scale. So
Jeevan, you want to package it. You want to package, make it an EXE. Is that what you're looking for?
Yeah. How do you make a product out of this?
Oh yeah, no, I'm going to cover that in the next 1 or 2 session, right? How do you create the executable and distributable, etc. Because if for the Python to execute, right? I have to talk about that, because how to compile it, how to link, how to package it with multiple libraries, etc., etc., etc. Right? So I'm going to cover.
Yeah.
That. Give me
great.
2 weeks. We will cover that topic before we go. So
thanks.
That's a good one. Okay. Anything else? My suggestion is to practice as much as possible. Just from my own experience, if you practice more, you will be good. Very soon, this will turn into a vector operations. By that time, I would expect all of you to have fluency in this, right? What I told last week is the vector operations means you're going to do parallel processing, like hundreds and thousands of rows will be manipulated in one time. So by that time, make sure that you know all these concepts. Everything we put in that slide is very important. So just be fluent on that.
Rajesh, I think you should probably give us some exercises. Maybe you can put it up in the forums so that we can look at it and then copy it and work on that, and then put the code there, and then maybe each other can look at the code and see if they're having any difficulties.
Yeah, let me try to put some exercises. I'll try to do that. And also, you put some books also, right? There's a lot of exercises.
Okay, sure.
So, and another one is you can just Google like Python exercises. You can get it, but I can put something. That's not a problem.
Yeah, I mean, if you can put what will happen is something that everybody will work on, and that way, if anybody has an issue with it, then they can talk to each other on the forum.
Yeah.
That
way. And you yourself can do that also, right?
Sure,
I mean,
sure.
That a relevant exercise is there, you can put that in.
Okay, sure.
I'll also put something in. We can do that. Just create a thread called Python exercises.
Okay.
And put that in. And the more you do, the more fluent you will be.
Sure.
So
Rajesh.
Yeah.
Your video, if you could come on the center of the video, that would be very helpful.
Okay. No, I was just stopping. That is why. Okay. So that's pretty much it. So we can stop here and we can continue next week. We will continue with what is that? Machine learning. The next topic, we establish the need for what you call
neural network.
Neural network. So let's go define what is neural network. Let's define the parameters and let's try to optimize it. And immediately I may switch to Python and show you how to calculate the gradient descent. So by that time I need to cover the vector operations.
That will be on Monday.
What is that?
That will be on Monday, right?
So please try to refresh that concepts on metrics, vectors, etc. Remember, I talked about a lot of things, right? Symmetry, associativity, like remember inverse, transpose, etc.
Yeah.
So the vector and metrics topic we discussed, if you could review, that would be great.
Sure.
That's pretty much it. I think we can stop here. I think make use of this time to learn a new skill, especially with this machine learning and Python. It means one of the challenge you may encounter if you go for general reading with the machine learning is the notations will be totally different, because every book I see has a different notation. So that could completely throw you away. So just stick with one notation, and once you're familiar with that notation, you can always change it. Just a practical suggestion. Okay, so Take care and stay safe because situation is getting really bad.
Yes.
Thank you.
Rajesh.
Thanks.
Thank you.
Thanks. Yeah,
Good
bye.
night.
Bye.